how the system works. Straddle vehicles operate in a fixed guideway called a straddle fixed guideway. The straddle fixed guideway is a series of LED lane markers called straddle fixed guideway markers that are retrofitted upon existing transportation corridors and are linked to the straddle traffic management system. The current freeway lane configuration is inside shoulder lane, HOV lane, standard lane, and outside shoulder lane. The current lane markers would be removed, and the straddle fixed guideway would be installed. The straddle fixed guideway configuration would be left straddle lane for the left vehicle wheels, right straddle lane for the right vehicle wheels, which would allow the wheels to operate on the outsides of the HOV lane. The straddle traffic management system is a traffic signal system that prevents collisions between straddle vehicles and traffic. The system includes straddle fixed guideway lane markers that include a circuit strip linked between the markers. Each marker has a marker lens and a housing with the LED. The LED lane markers broadcast a white color signal and a yellow signal. The solid and dotted yellow line would be broadcasted in front of the vehicle and in the rear of the vehicle. The straddle traffic management system would broadcast the signals as the straddle vehicle moves down the freeway and would tell drivers when it is safe and unsafe to merge in and out of the HOV lane crossing the straddle fixed guideway. The LED lane markers would display a white dotted line, which means you could merge in and out of the HOV lane. A yellow dotted line, which means you may merge in and out of the HOV lane with caution because straddle is approaching. A solid yellow line, which means that you may not merge in and out of the HOV lane crossing the straddle fixed guideway. This signal prevents collisions between the straddle vehicle and traffic. The straddle passenger stations would be retrofitted to the existing transportation corridors. This is the overhead view of a station incorporated with an overpass. The straddle vehicle would stop at the station and vehicles in the HOV lane would still be able to travel underneath the straddle vehicle. This is the side view of the overpass station. Smaller stations could be retrofitted to the existing transportation corridors. This is a rendering of a station retrofitted to Macy's at Ala Moana Shopping Center on Ala Moana Boulevard. A smaller station at King Street. A larger station straddling King Street. Types of loading would be conventional side loading, like subways and trains. Belly loading outside of a station. Belly loading at a conventional bus stop. The system will retrofit buses so that there may be technology to technology loading. Top loading. The driver of the straddle vehicle would have the option of switching the steering system to automatic, in which the onboard steering system would be controlled by magnets that detect magnet rail that is embedded in the fixed guideway. This would keep the vehicle steady as it traveled down the transportation corridor. Once the driver applied pressure to the steering wheel, the automatic steering system would disconnect from the fixed guideway, and the driver would be able to manually steer the vehicle.